Imagine discovering that the fundamental laws of quantum physics, the literal equations that dictate how matter actually exists, um, aren't written in some modern textbook,
Right.
but they're sitting in plain sight, carved into millions of tons of limestone in the middle of the Egyptian desert.
It's a huge shift in perspective.
What if you found out that an ancient civilization didn't just build a monument, but rather they constructed a functioning quantum machine? Because today, we're looking at a framework that claims exactly that.
Yeah, we are exploring a theory where the Great Pyramid of Giza isn't a tomb at all. It is literally a three-dimensional operator diagram.
Which is, it is a massive, massive conceptual leap. We were so used to the idea that the true nature of the universe is written in this invisible math language, right?
Absolutely. The kind that only supercomputers and particle colliders can really decipher.
Yep. Exact. Usually when we talk about fundamental physics, there's this expectation of a pristine, sterile laboratory. You smash subatomic particles together in a 27-kilometer underground tunnel. The computer spits out a staggering amount of data, and the physicist just points to a statistical bump on a graph and says, there it is. There's your reality.
Right. It's highly abstracted.
Very abstracted. We like things to be categorized neatly. Physics belongs in the math department, and ancient architecture belongs safely in the history department.
But when you step into the world of theoretical unified field models, especially those that try to bridge the gap between pure math and physical form, well, suddenly that pristine laboratory wall just comes crashing down.
Yeah.
You are looking at a theoretical landscape that completely shatters those neat little categories we've made.
And that is exactly where we are taking you today. So whether you're trying to wrap your head around theoretical physics, or maybe you're fascinated by ancient mysteries, or you just genuinely love a rigorous mental challenge that kind of turns your worldview upside down, you are in the right place.
Definitely.
Our source material today is a truly dense, absolutely fascinating manuscript. It's titled Great Pyramid Anchoring Geometry, written by George James Dukas. And it outlines a framework he calls Transdimensional Unified Field Theory, or TDUFT.
TDUFT. And it is a formidable piece of work, honestly. It operates at the very bleeding edge intersection of topology, wave harmonics, and some incredibly provocative historical thought experiments.
Oh, for sure.
It is basically suggesting that form, like specific, measurable, physical shape, is what actually dictates the behavior of energy and matter.
So the mission for this deep dive is to explore that exact mind-bending proposition. What if a physical shape is the literal mathematical anchor for a unified theory of physics?
Right.
But before we dive into the deep math, I really want to set the scene for you, the listener, because the source material comes with some incredibly vivid imagery.
It really does. And the visual component is crucial for understanding the mindset required to engage with this theory.
So picture this. You have these sprawling, sun-drenched cityscapes made of golden stone. Intricate geometric pathways lined with fountains, and they're leading up to colossal, perfectly proportioned pyramids.
It's beautiful.
And stamped everywhere on the temples, above the archways, etched into the very paving stones you walk on, is the Greek letter phi, the symbol for the golden ratio. It paints a picture of a universe and a civilization governed entirely by recursive geometry.
It's a very evocative visual, right? And it serves a distinct purpose. It's meant to orient your mind away from our current model of reality.
Which usually feels like a random, chaotic soup of particles bumping into each other.
Exactly. It points you toward order, toward a universe that scales perfectly with mathematical intention, from the microscopic all the way to the cosmic.
Okay, let's unpack this. Because we have to transition from that grand visual of a golden pyramid into the core mathematical premise of the paper. Before we can even talk about the physical pyramid itself or ancient Egypt or any of that, we really have to understand the universe it supposedly anchors.
We do.
And in this framework, that foundational universe is called the Eternum Nexus.
Yes, the Eternum Nexus. Now, to understand why this is so revolutionary, we have to look at how physics normally works.
Okay, break that down for us.
So in standard quantum mechanics, or the standard model, you usually start with a list of fundamental particles, quarks, leptons, bosons, and you also start with arbitrary constants.
Wait, hold on. Arbitrary constants. What do you mean by that?
Well, think about the speed of light. It's roughly 299 million meters per second, or the mass of an electron, or the gravitational constant.
Right.
Modern physics relies on these numbers to make equations work. But if you ask a physicist why the speed of light is exactly that number, they will tell you, well, we don't know. We just measured it. That's what it is. And we plug it into the formula.
Right. It's just a given. It's an ingredient we found in nature, but we don't know the recipe that actually created the ingredient.
Exactly. Standard physics just accepts those constants blindly. TUFT doesn't do that at all. It completely rejects the idea of starting with arbitrary particles and arbitrary numbers.
Oh, wow. It says the most fundamental thing in the universe is not a particle, but a geometric relationship. The eternum nexus is defined as the governing recursive creation relation. Governing recursive creation relation. Okay, that's a dense phrase. Let's translate that. A recursive relation, we're talking about a rule that repeats itself over and over, feeding back into itself, generating complexity as it goes.
Like a fractal, right?
Precisely like a fractal. If you look at a fern leaf or the branching of a river or a snowflake, you are seeing a simple geometric rule repeating at smaller and smaller scales.
Yeah.
But the eternum nexus isn't just any rule. The engines of this recursion, the operators that actually drive the universe to build itself, are based on golden ratio proportions.
The famous golden ratio, phi 1.618.
Yes, but it goes deeper than just an aesthetic number. The paper uses two specific mathematical operators to define everything. There is phi, which represents recursive expansion, and there is its exact partner, its conjugate, which the paper calls psi. Psi represents contractive closure. Okay, I want to pause on that word, conjugate. You said psi is the conjugate of phi. I don't want to lose anyone here, so what does that actually mean in plain English?
Sure. So in mathematics, a conjugate pair is like a perfectly matched lock and key. They are two numbers that are intricately linked so that when you perform basic operations on them, they cancel out their messy infinite decimals and leave you with perfectly clean integers.
Okay, I'm tracking.
In this specific case, phi and psi are a unique conjugate pair. If you multiply them together, their product is exactly -1. And if you add them together, their sum is exactly +1.
Oh, that's wild. So they're infinite, irrational, non-repeating numbers. But when they interact, they produce absolute, clean, binary foundations. A -1 and a +1.
Yeah. If we connect this to the bigger picture, it is mathematically beautiful. Phi and psi aren't just random numbers some ancient architect liked. They are mathematically inevitable if you are trying to build an infinite self-replicating system that can occasionally close in on itself to create stable structure.
Expansion and contraction.
Exactly.
It's like the breathing of the universe.
Yep.
Phi breathes out, expanding. Psi breathes in, closing and stabilizing. So if we have these two operators, what do they actually build in this empty void? The text says they generate an infinite lattice, an open, expanding field of radial shells and recurring polyhedral shapes, like tetrahedrons, cubes, dodecahedrons.
Right. So imagine standing in a perfectly dark room and dropping a stone into a still pond of water. You watch the ripples expand outward.
Sure.
But instead of just two-dimensional circular ripples on the surface, imagine three-dimensional geometric shells expanding outward in all directions.
Like invisible force fields stacked inside each other.
Right. But these expanding shells aren't completely smooth. Because of the interplay between expansion, which is phi, and contraction, which is psi, at specific, predictable mathematical intervals, the energy in those shells finds balance. It stabilizes.
And when it stabilizes.
And when it stabilizes, it forms closed, three-dimensional geometric structures, the Platonic solids.
So instead of empty space, we're talking about a reality that is structurally more like an infinite set of geometric nesting dolls, or like an endlessly expanding origami structure that folds out of the vacuum.
That is an excellent way to visualize it. It's a cosmic origami universe that folds and unfolds according to very strict topological rules. And the paper explicitly mentions Euler's relation as the topological check for these shapes that emerge in the lattice.
Euler's relation. Oh, this is a beautiful piece of math. Let's break it down for everyone listening, because once you see it, you literally can't unsee it. It's an equation. Vertices minus edges plus faces equals 2.
Exactly. For any closed convex polyhedron, meaning a 3D shape with flight sides and straight edges that doesn't cave in on itself, if you take the number of corners, the vertices,
Right.
subtract the number of edges and add the number of flat faces, the answer is always, invariably, exactly 2.
Let's test that live. Take a standard 6-sided die, a cube. It has 8 corners, and so vertices is 8. It has 12 edges running along the sides, and it has 6 flat faces. So 8 minus 12 is -4, plus 6 is 2.
Perfect. Try it with a tetrahedron, a 4-sided pyramid, 4 vertices, 6 edges, 4 faces. 4 minus 6 is -2, plus 4 is 2.
It's a universal law of shape. No matter how complex the geometric solid gets, as long as it's a closed system, it always equals 2. It's like a mathematical fingerprint for reality.
It really is.
But the author of this paper makes a really crucial point here. Euler's relation is just the check. It tells you the ship is valid. It doesn't tell the shapes how to grow.
Right. Euler's relation is just the building inspector. It proves the shape is structurally sound and closed, but it doesn't provide the blueprint.
Right.
The phi and psi operators provide the generative rule for how one shape scales up and nests within the next larger one. They dictate the actual scaling of the expanding shells.
I want to push on that scaling because this is where the paper gets incredibly precise and honestly a little intimidating.
Oh, the algebra.
Yeah, the algebra. It gives a specific algebraic rule for how these shells expand. I'm going to describe the formula, but then we really need to translate it so it actually makes physical sense. The paper says the radius of these shells expands according to the formula. R sub n equals R sub 0 times phi to the power of 2 times n minus 1.
Yep.
Now, reading math out loud in a deep dive is usually a terrible idea, so please translate that algebraic gibberish into a spatial reality. How does that actually play out in this infinite lattice?
Okay, let's strip away the algebra. What that formula is saying is that the distance from one geometric shell to the next larger one isn't random. It's not just slowly stretching. Each new shell's radius is governed by the square of the golden ratio, phi squared.
Okay, so it's jumping in size.
Exactly. Think of it like walking up a staircase, but every step you take is exponentially larger than the last one, perfectly proportional to the golden ratio. Shell 1 exists at a baseline scale. Shell 2 is instantly phi squared times larger. Shell 3 is another phi squared jump larger than that.
Wow.
It is an exponentially expanding, perfectly proportional scaffold.
Scaffolding, I like that.
Mhm.
So why should you, the listener, care about this infinitely expanding geometric scaffold? Why does it matter to your life right now?
It matters a lot.
Because if this mathematical premise holds weight, it means the universe you live in is not a random, chaotic accident. It means reality is a highly ordered architecture. It means the exact same geometric proportions that govern the spiraling arms of the Milky Way galaxy are the exact same proportions governing the microstructure of the atoms in your coffee cup. It repeats. As above, so below, but written in rigorous mathematics.
Yes. It proposes a universe of profound inherent meaning at a structural level. In this framework, there is no such thing as truly empty space. Space itself is just the lattice, waiting to be activated. It is governed entirely by the eternum nexum.
Right, an infinite lattice is, well, it's infinite. It's everything and everywhere all at once. If the universe is just this endless, expanding origami of phi and psi, how do we get a localized world? How do I get this microphone in front of me? How do you get boundaries and measurable things?
That is the single most important conceptual transition in the entire theory. And this is where the pyramid comes in.
Finally.
Right. Not as a symbol, not as a metaphor, but as a literal mechanism. We have to figure out how to move from the infinite, boundless lattice to a finite, measurable bridge.
Okay, so the infinite has to fold, which brings us to the bounded anchor, the 5-node, 8-edge bridge. The paper makes this very aggressive central claim here. It says the 5 pyramid is the overlaid geometry anchor. It is the finite metric realization of the infinite nexus.
The wording there is very deliberate. Finite metric realization. Think about the infinite lattice as an open circuit. The electricity is there, the potential is there, but it keeps going outward forever.
Right.
To have a physical reality you can measure, to have a local event like a particle or a planet or a person, that infinite relation has to fold in on itself into a closed, bounded form. The pyramid is that closed form.
And when we say pyramid, the paper defines it very strictly as a mathematical graph. It's not necessarily talking about the massive limestone blocks in Egypt right now. It defines it as a 5-node, 8-edge graph. Let's visualize that in our minds. A node is just a point. An edge is a line connecting the points. So you have one apex node at the very top. You have 4 base nodes at the corners of the square base. That's your 5 points, your 5 nodes.
And your 8 edges are the connections. 4 edges connecting the base nodes to form the flat square on the ground, and 4 apical edges slanting up from the base corners to meet at the apex. 5 nodes, 8 edges. That is the fundamental bounded geometry.
And the paper goes out of its way to push back on a very old, very entrenched philosophical idea here. It explicitly rejects the idea that this physical pyramid is merely a shadow of a higher reality.
Right. This is a direct rebuttal to Platonic thinking. Most people are familiar with Plato's allegory of the cave.
Oh, yeah.
The idea is that physical reality, the stuff we can touch and see, is just a flawed, blurry shadow cast on a wall. The true, perfect mathematical forms exist in some higher, unseen realm of pure thought.
Here's where it gets really interesting. We are so conditioned, especially in modern physics and math, to think of the equation on the chalkboard as the real perfect thing and the physical object in the real world as just a messy, flawed copy. But this paper argues the exact opposite.
Absolutely the opposite.
It says this 5-node, 8-edge pyramid is the actual tangible realization of the physics. It's not a shadow of the machine. It is the machine itself.
Exactly. The author writes that calling it a shadow implies a dualism, like a real infinite side of the universe and a fake or lesser finite physical side. This framework completely rejects that division. The infinite lattice and the finite pyramid are the exact same physics.
Yeah.
The pyramid is just the open lattice forced into a bounded, measurable regime.
But wait, let me play devil's advocate for a second. If the pyramid is the physics, does the pyramid generate the laws of physics? Is the physical shape creating phi and psi out of nothing?
No. And that's a vital distinction. The pyramid doesn't generate the golden operators. The hierarchy here is very clean. The eternum nexus is the source relationship. Phi and psi are the mathematical operators driving that relationship.
Okay.
And the 5-node, 8-edge pyramid is simply the most minimal, simplest closed form that can handle what those operators are trying to do.
Well, what exactly are they trying to do that requires a pyramid? Why not a cube? Why not a sphere?
Because they are trying to hold two fundamentally contradictory geometries at the exact same time. The paper calls this the tension between circular or spherical containment and square or polyhedral closure.
Oh, wow. Squaring the circle, the ancient impossible math problem.
Exactly, squaring the circle. Think about the geometry of a sphere. A sphere is a perfect, continuous, infinite enclosure. There are no corners, no edges, no starting point, no end point. It is mathematically smooth.
Yeah.
But a square, or a polyhedron, is a finite, bounded closure. It has distinct edges and nodes. It stops and starts.
Right. One is in infinite flow, the other is finite structure.
The paper argues that the specific proportions of this theoretical pyramid act as a geometric bridge between those two incompatible worlds. It is the minimal overlay that allows circular measure and square closure to exist simultaneously.
The paper actually gives an equation for this, and I want to try to translate it because otherwise it just sounds like math salad. The equation essentially balances two distinct sides. On one side, you have alpha and beta weights multiplied by phi and psi I. That represents the square, the rigid geometry, the corners.
Correct.
On the other side of the equal sign, you have pi squared. Pi, the universal constant of circles and spheres. So the pyramid operator is literally the equal sign.
Yes, it is the bridge.
Let's try an analogy. Imagine trying to perfectly wrap a rigid, square cardboard box with a perfectly spherical sheet of wrapping paper without tearing the paper and without crushing the box. It seems impossible.
Right.
The math equation in this paper is basically calculating the exact mathematical tension of that paper stretching over the sharp corners. The spherical closure translates through the pyramidal overlay into square polyhedral closure.
It's a brilliant translation matrix, the crossing point. You have an infinite spherical wave of energy from the lattice, and it hits this 5-node, 8-edge geometric filter, and it is forced into a localized, squared-off physical reality.
Okay, so we have this 5-node, 8-edge machine. We understand its shape. We understand it's a bridge between the infinite and the finite. But what is it actually doing? What is it operating? If it's a machine, what is the output?
This leads us directly to the most practical part of the theory, the physical outputs of this framework.
Matter.
And waves.
Right, the 1 and the 0, the grammar of creation. The paper states that the pyramid's 5-node, 8-edge graph actually splits into two distinct interactive sectors. There is an additive component and a multiplicative component.
And this right here is where TDUFT fundamentally replaces traditional quantum mechanics. In standard physics, you have particles and you have fields, and they interact in ways that are often modeled purely through probability.
Like Heisenberg's uncertainty principle, Schrödinger's cat.
Exactly. It's all about what might be there. Here, there is no probability. Everything is mapped onto the tangible geometry of that 5-node, 8-edge bridge.
Let's clearly define those two sectors. First, the additive component. The paper says this is the geometric structure itself. It's the physical stuff of the graph, the actual 8 edges and the 5 nodes. Each part of that structure is assigned a specific mathematical weight. You just add them up.
Think of the additive component like the steel scaffolding of a building. It is rigid, it is fixed, it is spatial geometry.
And then you have the multiplicative component. The paper describes this as the wave. Specifically, a standing wave coherence that lives on those exact same 8 edges.
If the additive component is the steel scaffolding, the multiplicative component is the wind blowing through the scaffolding, vibrating it. Or better yet, Think of acoustic resonance in a massive stone cathedral.
Oh, like that.
The stone walls are the additive geometry. But when a choir sings, the sound wave multiplies and reflects off those specific walls, creating a standing wave of pure resonance. That wave is the multiplicative sector.
That makes perfect sense. So you have static lattice geometry, additive and dynamic wave resonance, multiplicative, occupying the exact same space at the exact same time.
Mhm.
And the interaction between those two sectors generates what the framework calls a strict 10 projection rule, where 1 equals attachment and 0 equals separation.
What's fascinating here is how this redefines the very concept of matter. What is a particle? If you ask most people to draw a subatomic particle, they draw a tiny billiard ball, a microscopic speck of dust.
Right, a little hard dot.
TDUFT says that is entirely wrong. A particle is not a tiny object. A particle is an attached resonant closure.
Attach resonant closure. Let me make sure I've got this. Let's try another analogy. If I'm hearing this right, this model of reality is a lot like playing a guitar.
Okay.
The additive geometry, the 5-node, 8-edge rigid structure, is the wooden neck and the metal frets of the guitar. It's the fixed scaffolding. And the multiplicative wave is the vibration of the actual string.
That is a perfect analogy for what the paper is describing.
So when you play an open string, it just vibrates freely. But when you press your finger down on a specific fret, you force that vibrating string to lock onto the rigid geometry of the fretboard. That moment of locking on, that is attachment. That is the one condition. And when you force that attachment, you produce a very specific localized note. In this physics framework, that note is a particle. It's localized mass.
Yes. The multiplicative wave energy locks onto the additive lattice geometry. When they sync up perfectly, the energy becomes bounded. It becomes stable. And we, as observers, measure that localized, stable energy, and we call it mass or matter.
And then what happens if you lift your finger off the fret?
That is the zero condition, separation. The wave detaches from the specific geometric nodes and reverts to an open resonance. It is no longer a localized particle. It becomes a free-floating wave propagating back through the infinite lattice.
This completely breaks your brain if you really think about it. It means matter isn't a thing. Matter is an event.
Yes.
It is the momentary event of a universal wave locking onto a local geometric bridge. It's a purely harmonic geometric grammar. 1 is form, 0 is flow, attachment and separation.
And because this entire process is governed by the specific proportions of the Phi-pyramid bridge, this isn't just a poetic metaphor about guitars and cathedrals. It is an operator equation. It is a mathematically calculable threshold. We can predict exactly when the string will hit the fret.
Which means we can actually run the numbers. Analogies are great. The guitar string makes perfect sense to me. But the author of the paper actually provides the hard math to prove this finite bridge works. He evaluates the operator.
Which is absolutely vital. A theory can be conceptually beautiful. It can sound amazing on a deep dive, but if it doesn't yield measurable, testable values, it's just philosophy. It's just a nice idea. The author is very careful to provide the explicit mathematical derivation to prove its real physics.
So let's look at the numbers. The paper sets up the master operator equation. Operator of the pyramid, let's call it O, equals the geometric additive sector G minus the standing wave multiplicative sector, SO equals G minus S.
It is a difference equation. It is literally measuring the mathematical tension between the static geometry G and the dynamic wave S on that finite 5-node graph.
To test this equation, the paper uses what it calls a balanced case normalization. It sets the mathematical weights of the base corners at alpha equals 2 and beta equals 2. Which makes sense because 2 plus 2 equals 4, satisfying the 4 corners of our square base.
Correct. We are setting up a perfectly balanced, symmetrical square closure at the foundation of our pyramid.
Okay, when you plug those symmetrical weights into the additive part, the geometric edges and nodes, the paper calculates that G evaluates to exactly 5.
It's a remarkably clean integer result for the geometric foundation. 5 nodes, evaluating to a weight of 5.
Then we have to calculate the multiplicative part, the standing wave, the S. This uses a product form based on those exact same weights, but across the 8 edges. And the formula evaluates to a fraction, 3/2, to the power of 8.
And we need to explain why it's to the power of 8. That isn't a random exponent.
Right, I was just going to ask that. Why 8?
Because there are 8 physical edges on this pyramid structure. The wave isn't just sitting there. It has to travel across the entire structure. It multiplies its harmonic energy across every single one of those 8 edges to achieve a standing resonance.
Oh, wow. So the geometry directly dictates the math. If you run that calculation, 3 halves to the power of 8, it comes out to roughly 25.629.
So now we have our two concrete values. The static additive lattice is 5. The dynamic multiplicative wave is approximately 25.6.
Which means our final operator value, O, which is G minus S, is 5 minus 25.629. The final result is approximately negative 20.629.
And the immediate question any physicist or engineer is going to ask is, what does that negative number actually mean in the real world?
Exactly. We have this number, negative 20.6. How would a modern engineer actually use this? We've talked about galaxies and origami and cathedrals, but can we build a physical piece of hardware, a metallic resonator, based on these 5 nodes and 8 edges to see if this bridge operator actually traps a wave?
Yes. This is where the theory moves from paper to the laboratory. The number itself, that negative 20.6, is a measure of the baseline tension between the geometry and the wave in a perfectly balanced state. It tells you how far apart the two sectors are. Because the wave sector, 25.6, is much larger than the geometric sector, 5, the baseline state of this bridge is separation. It's negative. It's a 0 state. The wave is not locked.
Going back to our analogy, it's an open guitar string. It's just humming freely.
Exactly. But here is the physical pathway for an engineer. If you build a 5-node, 8-edge resonator hardware out of copper or quartz or whatever medium, you can start tuning the energetic inputs. You can alter the scaling. The goal is to hunt for the attachment threshold.
You're looking for the exact frequency where the string locks to the fret.
Precisely. You are trying to find the point where the geometric sector and the wave sector converge mathematically. If you can push the operator from negative 20.6 up toward that one condition, you have physically demonstrated the grammar of creation. You have forced a free, invisible wave to localize and lock into an attached resonant state purely by using the geometry of a 5-node, 8-edge bridge.
And if you can do that, you can predict resonance spectrums for entirely new materials.
Yeah.
You could map how one local closure cascades into the next shell recurrence. It provides a literal blueprint for a completely new kind of resonant technology. Energy generation, propulsion, computing, it changes everything.
It would be a technology based on harmony and proportion rather than explosive force and combustion.
Okay, so we have the math. We have the exact operator equation. We know the 5-node, 8-edge topology works on paper, and we know exactly how you would test it in a laboratory today with physical hardware. It is rigorous, testable physics.
Yes.
But the paper's title explicitly mentions the Great Pyramid. Why? Why connect a highly advanced, mathematically rigorous unified field theory to an ancient stone monument on the Giza Plateau?
Because the author proposes a deeply unsettling thought. What if we aren't the first people to figure this out?
And this brings us to the most controversial, fascinating part of the text. Chapter 7 introduces a historical thought experiment that completely shifts the context of everything we just talked about. It hypothesizes the existence of a geometry-first, ancient, megalithic culture, an antediluvian society.
We have to carefully define what geometry first means here because it requires us to step outside of our modern mindset. Modern society is highly compartmentalized. We separate physics, mathematics, theology, astronomy, and architecture. They live in different buildings on a university campus. The experts in those fields speak completely different languages and rarely talk to each other.
Right. The physicist uses algebra on a whiteboard, the theologian uses ancient scripture, the architect uses CAD software and blueprints.
But a true geometry-first culture wouldn't make those divisions. They wouldn't see them as different subjects. They would view all of those disciplines as different interfaces for the exact same underlying truth, the eternum nexus. To them, the recursive geometry that builds a subatomic particle is the exact same geometry that moves the stars across the sky, and it is the exact same geometry that should govern human structure and society.
So put yourself in their shoes. If you are this highly advanced ancient culture and you fully understand the 5-node, 8-edge operator that dictates how matter and energy interact, how do you store that knowledge?
Yeah.
You want to pass it down. You don't write an equation on a piece of parchment. It'll burn. It'll rot.
A written formula can be lost in a single generation. And even if it survives, the linguistic language it's written in will inevitably be forgotten or misinterpreted over millennia.
So what do? You build a giant stone hard drive. You use monumental architecture as a durable, millennia-proof memory device. You build a massive, perfectly proportioned, mathematically precise 3D operator diagram in stone. The Great Pyramid isn't a tomb. It is the physics textbook.
If we follow the logic of the hypothesis, the square base of the pyramid functions physically as the bounded additive lattice. It's stable, orthogonal, firmly anchored to the Earth. The four triangular faces provide the transition from that flat planar closure, slanting upward toward unity, and the apex is that unifying attachment point.
The one condition where the wave locks on.
The one condition, exactly. Where the separate flat paths of the base meet in a single bounded dimensional state. The very dimensions of the monument, the slant ratios, the specific base to height ratio, which notoriously recovers a value of 2 times pi, they aren't accidents. They are a permanent physical record of the bridge ratio linking recursive expansion phi and contractive closure size I.
It's incredible to think about. They wouldn't have described an electron using modern quantum vocabulary. They wouldn't talk about quarks or quantum spin. They would frame particles exactly the way the math we just discussed does, as attached resonant closures. Matter is just stabilized resonance. And they preserved this knowledge not just through one building, but through an entire integrated cultural system.
The paper outlines 4 linked forms of transmission this ancient culture might have used to keep the knowledge alive. First, architecture. That's the monumental geometry acting as the stable physical memory device.
The stone hard drive we just talked about.
Second, ritual. Now, this is important. Not ritual as blind religious dogma or superstition, but ritual as physical embodied instruction. Moving through specific geometric chambers in a specific order at specific times as a physical lesson in recursion, attachment, and separation.
Like walking through the operator equation with your actual body.
Yeah.
You literally step through the math.
That's exactly. Third, astronomy. Observing the cyclic rising and setting of stars, tracking the massive 26,000-year precession of the equinoxes. They would use the sky as a visible, large-scale, undeniable example of this periodic geometry in action.
And fourth, initiation, which the paper describes as the specialized, guarded transmission of the deeper operator meanings, keeping the core of physics intact among a select few, while the general public might just see the symbolic or religious layer. To them, religion and engineering were two sides of the same coin. The language of gods and cosmic order was just a long-term compression scheme for complex field relationships that are incredibly hard to preserve verbally over thousands of years.
Okay, I love this. It's a brilliant thought experiment. It feels like a movie, but I have to push back here. I have to play the skeptic.
Yeah, please do. Isn't it highly, highly possible that the ancient builders of the pyramids just, well, like the shape? I mean, a pyramid is the most structurally sound way to stack a bunch of heavy rocks so they don't fall down. The base is wide, the top is narrow. It's gravity and engineering 101. Are we just projecting our own incredibly complex, modern, unified field physics onto a pile of limestone?
Yeah.
We see the math we want to see. It's like seeing faces in the clouds, right? Pareidolia for quantum physicists.
That is the exact critical lens you have to apply, and it is the most common critique of any archaeoastronomy or alternative history. But you have to look at the specific tolerances.
What do you mean by tolerances?
If it's just a pile of rocks meant to not fall down, you don't need a base that is vertically leveled to within a fraction of an inch across 13 acres. You don't need the faces to be aligned to the true cardinal directions of the compass with a tiny fraction of a degree of error. You don't need the slope angle to be exactly 51 degrees and 51 minutes, which is the precise angle required to encode the golden ratio and pi. A pile of rocks doesn't require optical precision.
Okay, so the precision is anomalous. It points to high mathematical intent. But even still, could it just be a coincidence? Could they have stumbled onto these proportions just by trying to build something aesthetically pleasing?
The author of the paper actually agrees with your skepticism on a fundamental level.
Oh, he does. He doesn't claim it as absolute historical fact.
No, he is very rigorous about this distinction. The text states clearly that mathematical correspondence, even if the dimensions of the Great Pyramid match the TDUFT equations perfectly, which they appear to, is not enough to rewrite history books.
Right.
The paper explicitly warns against confusing the mathematical proof of the bridge operator with the historical proof of the monument.
So he separates the theoretical math from the physical archaeology.
Exactly. The 5-node, 8-edge bridge is mathematically sound within the TDUFT framework. The equations balance. But to prove that the Egyptians, or some older antediluvian builder, intentionally encoded the specific quantum physics, you need independent archaeological evidence.
You can't just use the math to prove the history.
Right. You need datable construction materials, verified tool marks showing how they achieved the precision, mathematical records from the era, or reproducible design constraints that uniquely support the physics model over just basic Really good masonry.
So until we find the ancient Egyptian equivalent of a laboratory notebook explaining the eternum nexus, it remains a hypothesis. A staggering, beautiful hypothesis, but still a hypothesis.
It is a profound invitation to investigation. The author is essentially saying, here is the math of the universe. The Great Pyramid seems to match this math to an astonishing degree. Let's look closer, let's keep digging, but let's not assume it's proven fact until the dirt and the stones corroborate the equations.
But framing it for you, the listener, whether this historical hypothesis turns out to be factually true, or whether it's just one of the most brilliant scientific thought experiments ever proposed, it completely shifts how you look at the progression of human knowledge. We always assume science has to progress in a straight line, from basic measurement to complex algebraic models to massive technological experiments like particle colliders. But what if there is a totally different path? What if an intelligence can start with pure geometry, build massive architecture based on that geometry, and arrive at a unified field theory without ever writing a single algebraic equation?
It suggests that truth is available through multiple interfaces. Modern math is one interface. Pure geometry is another. If the universe is fundamentally ordered by proportion, then studying proportion deeply enough in any medium, whether it's equations on a chalkboard or blocks of stone in the desert, will eventually lead you to the exact same foundational physics.
So what does this all mean? Let's take a breath and recap the journey we've been on today, because we have covered a massive amount of ground, and it is a lot to hold in your head at once. We started out in the infinite, the eternum nexus. We explored a universe that is not made of random particles bumping in the dark, but of recursive, expanding geometric shells governed by the conjugate operators of the golden ratio, phi and psi.
The open, breathing lattice of reality. Expansion and contraction.
From there, we zoomed in. We asked how that infinite lattice becomes local and physical. And we found the bounded anchor, the 5-node, 8-edge finite bridge, the pyramid structure, not as a metaphor, but as the direct, localized crossing point where spherical, infinite containment meets square, finite closure, the wrapping paper perfectly folding over the box.
We moved from the architecture of space to the actual grammar of matter. We saw how the additive geometry provides the rigid lattice, and the multiplicative standing wave provides the dynamic coherence.
The guitar fretboard and the vibrating string. We saw how 1 is attachment, the string hitting the fret, creating a localized particle. And 0 is separation, the free wave returning to the lattice. We even dove into the rigorous math of the operator equation. We saw how a geometric scaffolding weight of 5 and a wave resonance weight of 25.6 interact to create measurable mathematical tension, giving us an actual, testable blueprint for modern physical resonators.
And finally, we explored the staggering historical implication. The thought experiment that an ancient geometry-first civilization may have understood this entirely and built the Great Pyramid as a durable external memory device to preserve the unified field theory in stone for future generations.
It is a completely new lens through which to view reality. You walk away from a paper like this and you can't look at theoretical physics or ancient history or even the space around you the same way again. It unites form, matter, and waves into a single, interconnected geometric grammar.
It replaces a universe of accidental collisions with a universe of profound harmonic intent.
And I want to leave you with a final thought to chew on. Something that builds on this source material, but takes it one step further into your own daily life. The core argument here is that pure geometric proportion, a specific shape, like the 5-node, 8-edge pyramid, can act as a mathematical bridge, trapping infinite waves of energy into localized physical matter. The premise is that shape governs reality at the quantum level.
That is the central thesis, yes.
If that is true, if shape alone dictates how energy behaves and localizes, what does that mean for the biology of our own bodies? The double helix of our DNA is a highly specific geometric structure. It has proportions, it has a shape. Are our bodies just biological operator diagrams?
If the eternum nexus is truly universal, it doesn't stop at subatomic particles or ancient pyramids. It scales all the way up and all the way down.
Exactly. And what does it mean for the architecture of the cities we live in? Look at the room you are sitting in right now. Look at the dimensions of the walls, the height of the ceiling, the grid patterns of our streets. Are we right now unknowingly walking through and entirely made of geometric operator diagrams every single day? Is the shape of your living room subtly dictating the standing waves of energy within it? When we opened this deep dive, we talked about the pristine laboratory versus the ancient monument. We're so used to looking for the secrets of the universe in computer readouts and particle smashers. We look for reality in the math department. But maybe, just maybe, the unified field theory isn't hiding in a math textbook. Maybe it's hiding in the shape of the world all around us, just waiting for us to finally see the geometry.